Hey guys, Mr. Milton here. Today we're going to look at coordinate proofs notes. At the end of this video, you should be able to complete proofs of quadrilaterals using coordinates. Okay, so kind of set up how to use coordinates in our last section, and then we're going to get better at it here. Okay, so and to get better at it, basically, is going to be us deciding when to use the information that we kind of looked at using. So when do we use slope? When will we use distance formula? When would I use midpoint? Why would I do that? Okay, and so let's start off by just giving some general situations that you would. Okay, if you're asked to do a coordinate proof and you're asked to prove that opposite sides are congruent, right? Notice that these directions don't say, hey, use the distance formula. It says prove opposite sides are congruent. But you should say, oh, opposites congruent, sides congruent, that's distance. Okay, that means I should use the distance formula. Okay? If you were asked to prove that opposite sides are parallel, you said, okay, parallel, that in a coordinate plane deals with slope. If you're asked to prove that diagonals are perpendicular, again, that would be slope. Remember that with sides that parallel, it means it had the same slope. And if they are perpendicular, that means they'd have opposite reciprocal slopes. Okay. And if you were asked that the diagonals bisect each other, one way that you could do it, you could use distance formula, but you'd have to do that 4 times. Otherwise, you could use midpoint and show that, hey, these two figures have the same midpoint. That must mean that they bisect each other. Okay? So, it says, prove that the following figure is a parallelogram. Okay, so our thought process is, okay, how do I prove that it's a parallelogram? What do I need to do? Because you could use the distance formula or the midpoint formula or the slope on any 2 points, really. But you want to make sure that you're using the formula so that you're doing it efficiently and doing the work that you need to do and not a bunch extra. So my thought would be, what's the definition of a parallelogram? Okay, for a parallelogram, I need to know that both pairs of opposite sides are congruent. Or sorry, both pairs of opposite sides are parallel. There we go, parallelogram. Okay. And so, which formula would I use for that? I use slope. And so now what I would do is I say, okay, I need to prove that CD is parallel to BA. So let me do that here. What is CD? CD, okay, so I'm going to do y2, 2b minus y1 over 0, and I'm going to say plus 2a because it's minus 2a. So 2b over 2a, which equals b over a. That's the slope. Okay, and then I'll do the same thing for AB. Okay, so for AB, y2, 0, minus negative 2b, so plus 2b, over 2a minus 0. Okay, so that's 2b over 2a, b over a. They both simplified to b over a. So since CD and AB have the same slope, they are parallel. Okay, all right. So now I need to do that same thing with the other pair of sides, right? Just do a different color so that we can see where the work is separated a little bit easier. Okay. All right. So if I do that same thing with CB, excuse me, CB, 0 minus 2b, or 0 plus 2b because it's minus negative 2b, over negative 2a minus 0. Okay, and so I get 2b over negative 2a, and I simplify, and that gives me negative b over a. Okay, and I do the same thing with AD here. For that, I'm going to put 0 minus 2b over 2a minus 0. So negative 2b over 2a simplifies to give me negative b over a. Boom. Okay. And so I see that these are both negative b over a. Now notice that these two are congruent to each other. They don't have to be congruent with the other, or they don't have to be parallel with the other lines, right? It makes sense because they're going to intersect the other lines. Okay, that's how they close. So from there I can say, since both pairs of opposite sides are congruent, are parallel, their slopes are congruent, but since both pairs of opposite sides are parallel, the figure is a parallelogram. And it's important that when you do these coordinate proofs that you summarize what you've shown. Okay, so you don't just write numbers down and walk away. You say, this is the work that I just did. Okay, I showed that the lines are parallel, and so that must mean that the figure is a parallelogram. Otherwise, you just have a bunch of letters and equal signs all over the place. Okay. All right, so here's a couple more. It says, prove that the diagonals of this parallelogram bisect each other. Okay, remember that bisect means to cut in half. So how should we do this? I would think, let's find the midpoint of both of the diagonals. A couple ways that you could do that. You could say, hey, let's find the distance of this and that and that and that. But you have to find the midpoint even to find the distance between one of the edges and the midpoint. So just find that the midpoint, then you don't have to do the distance. If our midpoints are the same, if the midpoint of MT is the same as the midpoint of ER, then that must mean that they bisect each other. Okay, so if I'm looking for the midpoint of MT, okay, so MT, my X values here are A for both of those. So A plus A over 2, comma, my Y values, 2B plus 0 over 2. So that gives me 2A over 2, gives me just A. And 2B over 2 gives me just B. And so my midpoint of MT is AB. I'll do the same thing with R. I'll use, sorry, RE. Okay, so my X values for RE, so 2A plus 0 over 2. My Y value is 2B plus 0 over 2. So simplifies to give me just A, simplifies to give me just B, and we see that our midpoints for both of these are the same. So since the midpoints are the same, that means that the diagonals bisect each other. All right. And so there we go. That's what you did, show the work, and then summarize the work. All right, finally it says, prove that the diagonals of this rectangle are congruent. How will we show this? Distance formula, okay? When we're talking about being congruent, we're talking about a congruent length, so we're going to use the distance formula. Okay, and so what I want to do is I want to use the distance to find dB, one of the diagonals here. Okay, and so distance is the difference of the x's, so that's 0. Okay, so I'm going to say k minus 0 squared 0 minus m squared. And so that gives me k squared plus m squared. And that's it. Okay, remember that our negative square is going to come to be positive anyway. Okay, and we do that same thing with AC. Looking at AC, difference of the x's. So I have k minus 0 squared plus difference of the y's, 0 minus m squared. And so I'll do that step here, k squared plus negative m squared. But even when we do that negative times negative would be positive. So we end up with k squared plus m squared. Okay, and so we see that our diagonals have the same length. And so since the distances for each diagonal are the same, then we can find, or we can say that the diagonals are congruent. All right, that's it. See ya.